With example 3, we will have a repeating factor. The repeating factor is x squared plus 1. So to set up the partial fraction, since there's nothing else we can do, we're going to have x squared plus 1 plus x squared plus 1 quantity squared. To create this expression up here, we are going to look at the highest degree. The highest degree here is a quadratic. Therefore, our highest degree here has to be one less than the quadratic, which is a linear. So this is going to be ax plus b. This is also a quadratic. Ignore the square for right now. This is another quadratic. So this is going to be written out as cx plus d. I like to use different letters. In your textbooks, they will use a sub 1, a sub 2. It's easier if we just use different letters. So now that we have the two partial fractions, to find the value of a, b, c, and d, we'll go through the same process. Remember, in example 1 and example 2, the highest degree in the denominator was a linear. So one less than degree than a linear is a constant. That's why we didn't have an ax or a ax squared or anything, because the highest degree is 1, highest degree is 1, then we will have constants a and b up here. Okay, so going back to this, quadratic, highest degree is the linear. Quadratic in the denominator, highest degree is the linear. We'll go through the same process. This is missing an x squared plus 1. So we're going to multiply x squared plus 1. This factor here is not missing anything from here. So now let's continue to just write everything out. Since we have the same denominator, we can combine the numerators. We're going to have to distribute this. This is now ax cubed plus ax. Distribute. Distribute b plus bx squared plus b. Nothing to distribute here. Again, we have the same denominator, so we can just set our like terms. What you're actually doing with this denominator is you're multiplying everything by the LCD. Therefore, the denominators will be 1. So let's group them up now. Let's start with our cube. There's a cube, and that's it. So now, this is 2x cubed equals ax cubed. 2 equals a. So we found a. Next, quadratic. Quadratic, that's also it. So negative x squared equals bx squared. Therefore, negative 1, look at the coefficients, equals b. We just have to find c and d now. So here is our linear, linear, linear. 5x equals ax plus cx. So we're again looking at the coefficients. 5 equals a plus c. Well, since a is equal to 2, we could substitute that in. And again, to find c, subtract 2 from both sides. So c equals 3. Alright, there's no constants. So there's 0, but there is a constant right here. D and B. So D is a constant, B is a constant, no constant, so 0. Well, B is -1. So add 1 to both sides, 1 is equal to D. Well, now we have A, B, C, and D. We'll just substitute these values back into our partial fraction. This is now 2x minus 1. 2 in for A, B, -1 in for B. -1 times positive is -1. All over x squared plus 1. Plus C, which is 3, plus D, which is 1, over x squared plus 1 quantity squared. This is now equal to our original fraction. So here are the partial fractions for this original fraction.